different if you're using vectors. So when you're using vectors, it's not going to be y equals mx plus c. So let's have a look at what it is then. Let me see. So midpoint. We'll do a bit of each. Okay. So first we'll draw our line. So here.
What is the topic?
Equation of the line. Okay. So here is our line here, and here is our origin here. So you can think about your line as being made up of many possible points. So as an example, we'll just call one general point on the line or. Now please think about this. The equation of this line is y equals mx plus c. That's true. But if you're using vectors, the equation of the line is the equation that makes all the vectors that point at the line. So when I say equation of the line in vector form, I mean give me an equation that represents any vector and all vectors that point to the line. So it's the equation of any vector that points to the line. O or, yeah. So in other words, you want an equation that represents this vector that points to the line. Do you understand? Yeah? So, before you can do it, you need to know what the line is. So what's the minimum you need to make a line? The least information you need to make a line? Yeah, but in points.
2 points.
You need at least 2 points, don't you? So let's say in black we know A and B, and this is all we know. Yes? Okay, so the equation of this vector or here, you can say or equals O or, but if I want to use A and B, I could say, well, that's equal to OA plus A or. So far is that okay? What you're saying is O or is the same as OA plus A or. Yeah? But A or is the same as what? Yeah? It's kind of like AB except for one difference. Well, in this case it looks like double, but it will be some number, I'll call it T, multiplied by AB. And you don't know what the T is. And the T will be different depending on where the line is. So for example, if the T was 1, where do you think the or would be pointing? If the T was 1. What do you think? If the T was 1, where would the or be pointing?
B.
It'd be pointing at B. No, be at B.
Yeah.
If the T was 0, A.
Oh yeah.
Yeah. What if the T was a half?
Midpoint or
The midpoint of A and B. So different values of T will draw different vector lines. But what do they all have in common? They all point to the line. So this is actually our first formula. The equation of the line as a vector is or equals A plus T AB. And this, I'm telling you right now, the last time I checked, is not in the formula book. So, you got that? Yeah? So let's run through a quick example. Can I scroll down? Yeah. What are you writing? The formula?
yeah.
Right, so here's our first example. Right, so actually before I do an example like this, KJ, you already used the word midpoint, but just in case people don't know it, what is the midpoint of the vector A and the vector B, for example? So how could you find this midpoint here? Any ideas? No? What would it be? It will be vector A plus vector B divided by 2. Or if you want, it's a half of A plus a half of b. Now, if you didn't know that, you should write that down. Okay, can I, one? Right, so, in this example here, I have the point, let's call it 1, 1, 2, and the point 2, 1, 0. And I would like the equation of this line. So the formula, r equals a, 1, 1, 2, plus t ab. Now how do I get ab? How do I get ab?
A, B, B minus A.
b minus a. b minus a.
Yeah.
So 2 minus 1. 2
One.
minus 1, 1. 1 minus 1,
Zero.
0. And 0 minus 2, minus 2. This is ab. So then r equals 1 plus t, 1, and 2 minus 2t. That's the answer.
What do you want to?
Multiplied by t and add them together. See, this t here,
Yeah.
I multiplied it in
Yeah.
and added together.
And with 1, 1, 2.
Yeah, naturally.
T1, so it won't be 2t,
Where?
the first thing.
Why would it be 2t?
Oh, no, so 3, 1, oh, no.
2 minus 2t.
2, yeah. Minus 2.
Yes?
How do you now choose the t?
What?
How do you choose the t?
You don't. The t represents different vectors. You can find the t for certain situations, but you leave it as t because different t's draw the different vectors. So for example, if I put t 0 into this, what vector do I get? 1, 1, 2. What vector is 1, 1, 2? A. If I put t is 1, what vector do I get here? 2, 1, 0. If t is 1. Yes? What vector is that? The final one. Different values of t draw different vectors.
So if you find the midpoint, you just put t.
If you wanted the midpoint, you'd put t as a half. Yeah?
Yes.
Exam, how, the question, how would be asked, like what?
Exactly like what I would give you. They'd give you 2 points and say, here is point A, here is point B, find the vector. They might not even say vector. They might say find the equation of the line from A to B, but because it's vectors, 1, 1, 2 and 2, 1, 0, they mean the vector equation of the
Can
line.
we do that like some similar one?
Huh?
Can we do an example similar?
Of this one? Yeah.
Like a proper example.
No, this is what you get in the exam. Like the question would say, you know, if vector A equals 1, 1, 3 and vector B equals 2, 3, 4, find the equation of the line from A to B. So the formula, R equals A, 1, 1, 3, plus T, AB. AB is B minus 8, so that would be, what would be the first one? B minus 8? Come on.
1.
1.
0.
No, next one. 2, 1. Yeah? So this simplifies to 1 plus T, what's the next one? 1 plus 2T and 3 plus T. So this represents all the vectors that point to the line. Whatever vector you want that points to the line, you just need to find the value of T and you've got it. That's it. Yeah. Yeah.
If you want to write it in the I and J form.
Yeah, if you want to write it in the I and J form, it will be I plus, well, there's 2 ways to write it. You could write it as 1 plus Ti plus 1 plus 2Tj plus 3 plus Tk. Or if you wanted to separate it out, no, actually you would just leave it like that in the exam. Yeah. I, J, and K. We get this? Okay, so if you remember, this is when you have 2 points, but there are other ways to make a line. If you think back to semester 1, I can give you 2 points, or what else?
2 points.
Yeah.
The different lines, so we can.
Yeah. So
Parallel.
parallel, right? So let's look at what we need to do if we have a parallel situation. Can I scroll down? So for example here we have, let's say only point A. And here we have, for example, point B and point C. And I want the line that goes through A, but is parallel to the line that goes through BC. So this is the line that I want. And these are parallel. And let's write down some examples. A, B, and C. So for example, A could be 1, 1, 1. B could be 2, minus 3, 2. And we'll say C could be 2, 1, 4.
points.
Yeah. Can I go back?
Yeah.
These are supposed to be parallel.
They're supposed to be parallel, correct. Now, just before I go on, if you actually look at this formula, in semester 1 you had a y equals m, but I'll write it backwards. I'll write it y equals, let's say, a plus bx. This would be an equation of a line. So if you look at this, you can kind of see a comparison. What would you call the b here? The slope, the gradient, isn't it? So in this formula, this part here is a little bit like the gradient, because this AB vector, can I draw it here? See? The value of AB determines which way the line is pointing. Whereas what does the value of A do? It fixes the line in one place. So if you change the A, here, here, or here, you're just kind of moving a point on the line. But the vector AB, if you change the AB, what are you changing about the line? The way it's pointing. So the AB, we don't call it a slope. Well, we can call it not a slope, we can call it a gradient. The AB vector is like the gradient in semester 1. So if 2 vectors are parallel, what do you think? Just like with the lines, they have the same AB value. Yeah. But this kind of makes sense because with vectors, if 2 vectors are parallel and they're the same length, then they're the same vector, aren't they? Yeah. So let's go back to this one anyways. So what do you think I need to calculate first? BC. No, just BC is enough. So BC equals C minus B. What's that? C minus B.
C minus
Yes.
0 minus
4. Then 2.
So if I go over to this line, if I draw a parallel vector on it, what is the value of this vector that I'm drawing in red?
BC.
Yeah, it has to be the same, 0, 4, 2. So once again, you just use your formula, or equals A, 1, 1, 1, plus T, not AB because B is a different letter here, but like the AB part, 0, 4, 2. So the answer is or equals 1, 1 plus 4t, and 1 plus 2, 2. Okay. We got this? Yes? Yes? Okay, continue down. Yeah. Right. So now this time, another common question in the exam is they give you two lines and they ask you where they meet. So in semester 1, if we have two lines and they're not parallel, will they always meet? Yeah. They must, right? In 3 dimensions, if you have two lines and they're not parallel, must they always meet?
Yes.
Which is it?
What?
If you have two lines in 3-dimensional space and they're not parallel, must they meet?
Yeah.
No.
Depends.
So must they meet?
No.
No. So they'll give you two lines that do meet, but they don't have to meet. It's important that you know that. So in the exam they sometimes ask you to check if they meet. The way that you check if they meet is you try to find where they meet. If you succeed in finding where they meet, then you've proven they've intersected. If it fails to find the point where they meet, then you've proven that they don't intersect. Let me give you an example, okay? So I'll just pick numbers here.
2 lines or 3 lines?
2 lines. So the first line will be it'll be 4 minus 10t I plus 4 minus tj plus minus 6 plus 3t k. And then the second line will be 2 plus 8. Now I won't use the letter t again because I've used that for the first line, so I'll just call it f. f I plus minus 9j plus 18 plus 15s k. And we'll call this line or1 and we'll call this line or2. So let's see, do we have any ideas on how I could find where these two vector lines meet?
You can equate them.
Equate them, yeah. So we need to make them equal. Are you listening, KJ?
Yeah.
Are you sure? It looks like you're thinking about something.
No.
Are you sure?
Thinking about the lunch.
Yeah, you have that look about him. Hungry look. Did you have lunch?
Yes.
Breakfast?
No.
So you're a little hungry.
I woke up in the afternoon. Or
Yeah, he missed the first class.
yeah.
Afternoon? Sounds like you missed more than the first class.
Okay, no, the morning was
Okay, right.
Started with 11.
Okay. You made it to school at what time?
11.
11, and you live on campus, right? Okay, so you're right, Fahad, we need to equate them. So what do we equate? What do we say is equal? Yeah, R1 equals R2, but what can we make from that? So you're right, it is R1 equals R2, but what can we make from that?
You make it equal to the other thing, the whole thing is equal to 0.
I wouldn't do that, no.
R1 minus R2.
No. If two vectors are the same, it means their I, J's and K's are the
You
same.
can cancel them.
No, what you can say is 4 minus 10t equals 2 plus 8s. 4 minus t equals minus 9. Minus 6 plus 3t must equal 18 plus 15s. That you can make 3 equations. Can you see that?
Yep.
Now is that clear? This is important, yeah? But how many variables do we have? No, we don't, no. 2 only. S and T. But we have 3 equations, so what does that mean?
Different TTs.
S and T.
Yeah.
But you have 3 equations and only 2 unknowns. What does, oh, it's good, but what does it mean?
You can confuse them.
Not quite. You can use any 2, but, and this is important, you must confirm that the third one is true for your answer. Your question is not complete until you do that. So for example, I use the first 2 and then I keep the third one to check that S and T are correct. If it fails on the third equation, it means there is no intersection point. Now the reason I picked the first two is because the second one I can easily get t here. Minus t is 13.
Yeah, T 30.
So I have 13, I can put that in here, and I can get 4 minus 130 equals 2 plus 8s. Is that right?
Mm-hmm.
So, let me see, 132 minus 4, 120, it's like 128 divided by 8, I think is the s, which is 64, 32, 16?
Yes.
No.
16.
16?
Yeah, I got it.
You mean to say I got it? So I got s is 16. You must check in the last equation. So you take your t and your s and you check it in the last one. So,
Supposed to be minus?
thank you. Yeah, minus 16. Isn't it? Yeah. So, minus 6 plus 3 times 13. What's that, Fahad? And KJ, can you check the side on the right? 18 plus 15 times minus 16.
33.
33, and here? That's looking bad.
Minus 2.
Does the question ask if they meet?
Yes.
No.
Find where the two lines meet.
I didn't solve my equations wrong, did I? Or I didn't write them down wrong, did I? Minus 4, let me just check. Minus 4 plus, 4 minus 10. Rats. I made a sign mistake in the question. The question actually had a plus here. We'll fix it in a second. That's going to be the reason why. I mixed up question A and B. But that's fine, because that means here,
They don't mean.
therefore they do not meet, which you get in the exam as well. Let's pretend that they did meet. How can I find the point where they meet? Yes, correct. You can put the t value into the first one, or you could put the s value in the second one. They should be the same answer because they meet at that point. It means they're the same point. Okay, so this isn't actually, when you think about it, really this is just linear equations. It's not too difficult. So as an exam question in section B, it's quite good. Okay, can we do the next type?
Yes.
Yeah. So let's say I have this line here, and this line here. Well, I'll draw properly. That line here, and we'll call this one line 1, and this one here is line 2. So for line 1, we'll say the equation of the line. I'll write it in this bracket form. I'll write it out. 4 minus 10t I.
You said minus.
No, I haven't said anything yet. 4 plus tj plus minus 6 plus 3t. Okay, that's a plus 3t.
6 plus 2t.
Is that minus 6?
Yeah. And then line 2 will be 2 plus 8s I plus minus 7 minus 12s j plus minus 8 minus 5s k. Got that?
Yes.
Yeah. So this question here is that they want the pen line. Here we want the angle between the two lines. Yeah?
Mm-hmm.
So of course the lines have to meet for this to make sense. So they'll give you two lines that meet. And usually what happens in the exam as a section B question, they give you two lines, then they say prove that they meet and find where they meet. And then the next part will be find the angle between the two lines, something like this. Okay, so You remember the formula for the angle between two lines? What is it?
Between two lines.
Yeah.
Uh,
R1 dot R2 over magnitude of R1, magnitude of R2. Remember that? What is the R1 here?
I don't know.
It's not, because the L1 is the equation of the vector. What's my? It's the equation of this vector that points to L1. It's not actually on L1, so it's not L1 then.
We need to find it.
So you need to find what?
The mag. No.
You need to find the 2 points.
And we can make 2 points and then like the point.
You could find 2 points on the line, right, and make the vector. But if you were to kind of write this in, dun 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 dun. There we go. If I write this in bracket form, so that would be, what's the first one was 4 plus 10t, wasn't it?
Minus 10.
Sorry, minus 10t.
No, you wrote plus. Change it.
Did I? I thought it was mine. No, I didn't change it. Yeah. So if I write this as brackets, I could write it as 4, 4, 6 plus t times minus 10, 1. Oh, that's a minus 6 and 3. Let me just. This is 4, isn't it? 4, 4 minus 6.
No.
Minus 10, 1, 3.
Oh, minus plus 6.
This is a minus 6. See?
Where is the minus?
Right there.
Is it minus?
See? Minus. Yeah. Now, why do you think I wrote it like this? What's useful about having it written like this?
Now you know 2 vectors pointing to 9.
No, better than that.
You know the vector A,
Yeah, what's the vector AB?
the 4, 4.
No.
B minus A.
Remember, this is the vector AB in the formula. Remember? No, if I had you in that face like you don't remember.
I'm not able to figure out things.
Okay. Do you get what I'm saying? That this is like the AB.
So plus A.
Huh? Yeah, go on, yeah.
If plus the left can know B.
But we don't need to know B, we don't need to know A. We just need to know AB, the vector on the line. So this is on the line L1. What's the vector that's on the line L2, that's like the AB for L2? Well, you can do the same thing, can't you?
Mm-hmm.
So it will be, what would it be? 8, very good, yeah. Minus 12, yeah. Minus 5. So if you use these vectors, you can get the angle. What part?
Like 8 minus 12 minus 5.
Yeah, Taken. How did you get 8 minus 12 minus 5?
The coefficient of S.
Yeah, it's the numbers in front of the S. Because if you go back to the formula, the numbers in front of the T or the S, that's AB. AB is the vector that's on the line. So the numbers that are in front of the T, that's the vector that's on the line, pointing where the line is pointing.
What are we going to use them for?
Well, we can use these two vectors in the formula for the angle. Remember, cos theta equals?
Yeah.
So it would be minus 10, 1, 3 dot 8 minus 12 minus 5 over square root, let's see, 100 plus 1 plus 9, square root 64 plus 144 plus 25. What's that when you're ready?
The first one is 110.
Okay, you're giving me like that. Alright, so this is square root. Well, I know that. And this one here is square root of the. And on the top we'd have minus 80, minus 12, minus 15. And this is 225? Is that right? No, it's not. 233? That's
The bottom.
of the bottom.
Yeah.
Right, what's that? 160,
One is this one.
160.09. And on the top you'd have minus 92, minus 107.
Minus 107.
Oh.
You typed it in wrong.
Yeah.
Minus 107.
Right, so what's the theta, the angle here between the lines is cos inverse minus 107 over 160.09. So what do you get there? 131. Now, okay, 132 is it?
Yeah.
Is 132 the answer? No.
No.
Because when we have two lines together, they'll make two angles. An obtuse angle or an acute angle. We usually use the acute angle, so we should do 180 minus 132. 48. Yep. Got that? Very common question in the exam. Very, very common. Right, there's one last type to do. Continue? Yep. Right, so the last type is when you have a line, L1, and a point that's not on the line. So here, for example, this can be the point 5, 4, 7. And this line here can be the line minus 4, 6, and 9 plus t times minus 4, 6, and 9 minus 1, minus 1, minus 17. So what might you want to know if you have a point in a line? Well, one thing you could work out is the shortest distance between the point and the line.
The R is
Yeah.
given in the question.
Yes, in this
What
one.
is
it is.
distance between?
A point and a line.
Why would you want to do that?
Well, for example, if this is a mechanics physics problem, you know, like what's the closest car, particle, ship, building, plane gets to the thing you don't want it to hit. Right? So shortest distance is important.
What is question 3?
The question would be, what is the shortest distance between this point and this line?
Okay.
Okay, so I'll put the origin down here. Right, so this here, O, or, I'll call this point here or, and I'll call this point here C.
But you already have
Yeah, and I already have or, but I don't know what the T is.
right.
Yeah. What's special about or C compared to the line L1?
They're parallel? No.
That's the wrong word.
Perpendicular.
Yeah. Or C, yes, is perpendicular to L1. What is the direction of L1? What is the vector on L1 that points to the direction of L1?
Minus 1.
It's this one here, isn't it?
Yeah.
So or C is perpendicular to minus 1, minus 1, minus 17. Right? If two vectors are perpendicular, what do you know about their dot product?
Yeah, and 9.
Yeah, but the dot product.
0.
The dot product between or C and this vector
Yeah.
is 0. But what is the vector or C? What's the formula for or C?
C minus 1.
C minus or. Dot minus 1 minus 1 minus 17 equals 0. Right, do you know C?
Yeah.
Yes. And do you know or? You do. It's minus 4 minus T, 6 minus T, 9 minus 17T. So we'll do this one minus this one. So what do I get here? If I have minus 1 minus this. Minus 1 minus 4? sorry, minus 1 minus minus 4,
Why are you minusing that one?
because there's a minus here.
Minus
Which one and which one is minusing?
Can you write that? It's confusing.
C
But that's,
or,
but
Just
that's
write
in
it down. It's confusing.
write what down?
But that is in C.
This is not C.
That's L1.
Oh yeah, that's the one. That's the C.
Oh, thank you. Where's my C?
On the
You see that?
Here it is.
that's write it down. It's more.
Yes. This one and this one. So C minus OR will give me the OR C,
One.
which is here. Yeah.
This one.
Okay, let me write in. Right. Minus 1.
Oh.
Hang on, I got it. Sorry. 5 minus this.
Yeah.
What's that? 5 minus 4?
1.
9.
Thank you, 9. And then minus t?
5T. Plus 5T.
Minus t.
Plus
T. Yeah, you're writing down 5 minus 4 minus t. That's 5 plus 4 plus t. That's 9 plus t. Okay, what about the next one? That's going to be, I'll do it in blue. 4 minus this. What do you get?
2 plus T.
No, 4 minus 6 minus 2.
Okay, that was 2.
Minus t
Plus T.
plus t. 7 minus this.
Minus
2.
2.
Yeah.
Then.
Plus
17t. Dot minus 1 minus 17 equals 0. So do you remember dot?
Multiply.
9 plus t.
Do you know what
Yeah.
you think of?
That's equal.
Someone you don't like, just cross.
No. Dude.
It's easy. Take the hand. Switch off.
Yes.
Not this time. Someone, you know, you could take
So you have an emergency. Like
Nobody ever has an emergency that they need me for, okay? So, yeah.
I don't care.
9 plus t times minus 1 plus minus 2 plus t minus 1 plus minus 2 plus 17t times minus 17 equals 0. Now, I don't have time to finish it, but just answer me this. Could I get t from this?
Yes.
Yeah, you could get t.
Easy.
And easy. And if you have t, then you know the OR, because you just put the t in here.
Yes.
So if I know the OR, and I know the C, can I know OR C?
Yeah.
Definitely.
And if I know OR C, can I know the magnitude of OR C?
Definitely.
Definitely. So then you found the shortest distance.
Oh.
Okay. Now you see this question is kind of long, that's why it's a section B question. Yeah?
Can you just scroll up?
Yeah, well I'll zoom out a bit, is it?
Yeah, okay, now let's go.
Yeah. Now, you need to practice these because I'm not joking. I think I've seen this in every exam ever. This one page. Next week we have the proofs. And then we still have practical problems.
So what's the last word? R-E-T-T?
Get T.
Do we have to do the proofs in the exam?
I've seen proofs in the exam twice.
In 14 years, I mean.
And in fact, both times have been recent.
Have you what, Christian?
Proofs. What is this? What topic? Huh? Yeah, what topics? Oh yeah. Huh?
That's the book.
Temporal and interference.
That's yours.
This?
Should we come to your office to get the labs as well?
I suppose so, but can you give me a few minutes to make coffee?
Yes.